Alright, so this is really part 2 of the Limiting Reactant podcast, and we're just going to go through an example here. So here's our question. Given the following chemical reaction, and it's already been balanced, I'm going to read it as it's balanced. 1 mole of diiodine pentaoxide plus 5 moles of carbon monoxide yields 5 moles of carbon dioxide plus iodine. So the question really asks, if you had 15.5 grams of I2O5 and 13.84 grams of carbon monoxide, how many grams of iodine would be formed, and which is the limiting reactant? Alright, so our reactants, remember, are the things on the left side of the arrow. So these are our two choices for limiting reactant. And the way we're going to set the problem up, if you saw the first podcast about s'mores, graham crackers, marshmallows, chocolate squares, well, we have really two different things we can react. Alright, so we're just going to set this up as fence and rail, and we're going to go from gram to gram. So the first thing we're going to do is we're going to start with 15.05 grams of diiodine pentoxide. Alright, so it's going to be a mass-to-mass problem, so it's just a full-on stoichiometry problem. So we're going to go from grams to moles, and this is grams of I2O5 to moles of I2O5. Okay, and if we have moles and grams in the same fence post, that is known as molar mass. Where do we get the molar mass? We get it from the periodic table. And it's always 1 mole. Alright, then we're going to have to find 2 iodines plus 5 oxygens, and that all adds up to 333.806 grams. Okay, so if we divide, we're going to get moles of I2O5. So the next part is we want to do our mole ratio. So we're going to go from moles of I2O5 to moles of just iodine. And for this one, notice we have 1 mole for every 1 mole. So it's just a 1-to-1 ratio. The next thing we're going to do is go from moles of iodine to grams of iodine. And iodine is pretty heavy, so for every 1 mole of iodine, it weighs 253.089 grams. And that's 253. Alright, so notice grams of iodine, diiodine pentoxide, cancels, moles cancel, moles cancel. So we're just going to multiply across the top, multiply across the bottom, and simplify. And what we get is 11.44 grams of iodine. Okay? So really that's saying if we start with graham crackers, that's how many s'mores we can make. Alright? So now the next thing we need to do is we need to start with our other reactant. And our other reactant, notice, is 13.84 grams of carbon monoxide. And sometimes, we'll see how this plays out once we do the math, the limiting reactant is not necessarily what you start with smaller of. Alright? So we need to really do our fence and rail and see, because molar masses of things are different, mole ratios are different. So again, we're going to go from grams to moles, because that's what we do in our first step every time in stoichiometry. And for every 1 mole of carbon dioxide, it weighs quite a bit less. It only weighs 28.01 grams. Alright, now we're going to do our mole ratio. So we're going to go from moles of carbon monoxide to moles of iodine. And notice this is a 5-to-1 ratio. And then lastly, our last fence post is going to be exactly the same. We're going to go from moles of iodine to grams of iodine. And if you've already added it above, it's going to be the same number, so still 253.089 grams. And again, all my units cancel out if you go double check that. So if I multiply across the top, multiply across the bottom, and simplify, I get this as my answer. 25.08 grams of iodine. So just with a s'more example in the first podcast, whichever is the smaller one is really the correct one. So what is our smaller mass? It is the top one. So this is really how much iodine we can make. Alright? And then what is the limiting reactant? The limiting reactant is whatever reactant we began with to give us the smaller value. So in that case, the one that we began with was diiodine pentaoxide. So our limiting reactant is diiodine pentoxide. How much iodine can we make? 11.44 grams. And again, notice it has nothing to do with how much we started with, because we started with quite a bit less carbon monoxide, but because of molar masses and mole ratios, we actually end up making more iodine with the carbon monoxide. So that is your example of limiting reactant. You're going to do 2 fence and rail problems and solve, and your answer is whichever is the smaller value of the 2.